Hi, I hope I'm audible. My name is Gopi. I'm a machine learning engineer and I'm currently an AI fellow here at People Plus AI. So, People Plus AI is a non-profit initiative by Nandan and Rohini Nilekani Foundation. We work on building AI digital public infrastructure for solving societal problems. So, I have with me Bharat Shetty, my co-anchor in the project. So, interesting fact about both of us. We both are coming from the overall spectrum of deafness. We are this project Sunva is our attempt to solve a real world challenge we face every day in our life. So let's dive into the project. So based on the internet, it says that there are 65 million plus deaf people in India. But unfortunately, more than that, we don't have many information, statistics, and all. But I think it's more than 65 million people are there. But when people hear about deafness, people just think that, okay, it's just a deafness. But there are different spectrum. And unfortunately, in India and mostly around the world, there are no specific solutions catered for each of these spectrum, and that's causing a lot of issues like in education, employment. In my school and college life, I struggled a lot to listening to lectures and taking notes and all. It's still there. It's still not solved there. So we both are coming from a spectrum called oral spectrum. I'll just, for context, I'll just give you an explanation of what it is. So the oral spectrum includes individuals with a poor speech clarity, so people who can't speak properly. And then it includes people with excellent to medium to excellent hearing challenges or medium. So people with a poor speech clarity or 80 to 90% speech clarity, but then narrow to medium hearing loss. So these are people who can understand you by unconsciously lip reading. It's not a superpower. We can just do that from here and there. But again, unconsciously, based on practice, unconsciously we'll be able to do a combination of lip reading and somewhat we hear. And then there are people with a profound hearing loss. They are also in the oral spectrum. But the key fact is that we cannot build a one size fits all solution for all spectrums. So one need to understand the problems and then again figure out how we can tackle these problems. So that is one thing. So let's dive into how deaf people in the oral spectrum communicate. So lip reading, like I said, it's an art, but again, it varies from people to people and situation to situation. Sometime I can properly do the lip reading plus what I can hear to understand you, but sometimes it will be very hard. So what we do, we use real-time captioning tools. But there are issues like so my co-anchor Bharat is using a real-time captioning tool. But the problem with the real-time captioning tool is the rate of words or sentences, it varies. Say, for example, I talk a lot and I talk sometimes very fast. And if that's the situation, the real-time captioning tool will be bombarding you with the live transcriptions. And conversation is not just understanding what the other person is speaking. It's basically taking the visual cues, their expressions, and then if somebody is presenting something here, I need to constantly switch my attention from the transcription screen to the presentation screen to the people around me. So it's a very big challenge, and it causes this cognitive fatigue. It's still there, and so a lot of folks with a higher hearing loss, they cannot speak well. So you can think it like, okay, they'll be speaking in a muffled voice, or basically you won't be understanding them properly. So what I have seen is my speech is kind of okay, but I still have issues with pronouncing some words. But again, these folks, what they do is they write or type and then show it to you. So the problem there is like there'll be a lag in conversation, and it takes a lot of time for the normal hearing folks to read. So two problems will happen. The conversation health will be that energy, excitement will lose. That chances there. And second thing is, hearing folks often don't pay attention to the chat and all. Say, for example, if somebody is in the online chat, I mean, the online folks will understand because you folks might be typing something, questions and all, but yeah, we are not able to see that thing. So that happens a lot. So these are two challenges we face every day. Now I will dive into the demo and then let's get into the specifications. And
Sunva is an intelligent communication tool we built for solving communication challenges for deaf people in India. At its core, Sunva provides intelligent live transcription and seamless text-to-speech interface for making communication easy. Now, let's see Sunva in action. I'm going to click on the microphone and show how it works. Hi, I'm Naima. I'm an employee here at people+ai. Sunva is an intelligent communication tool built for helping deaf people in India communicate better with the help of AI. See here, I introduce myself. As you can see, Sunva noticed the above transcription is a casual intro which can be simplified for quick reading. A deaf person can have a glance at the simplified conversation and get back to the other person without reading the whole sentence. I can click here on the original and it shows me the original text. If I want the summarized text, I'm going to click this button. As you can see, it works really well. Now, let's see another scenario. TensorFlow is a machine learning library we are using at work. We use the library for training AI models and deploying AI models. Here, as you can see, instead of simplifying the text, Sunva highlighted important keywords, helping a deaf person to read the sentences quickly without losing important information by glancing over the important keywords. As you can see, it's highlighted TensorFlow, machine learning library and AI models. Again, you can click on original to see the original text and click on enhanced for the highlighted text. Now, let's see a different mode. Due to the lack of early intervention and lack of speech therapy, a lot of deaf people unfortunately have non-standard speech. For helping them to express what's in their mind, Sunva provides a seamless text-to-speech interface. I'm going to click on the keyboard icon, pick my gender and type into the box. I'm going to make some grammar mistakes to show Sunva's capability.
I am Neema, an employee at people+ai.
I can once again click on the button to show the original text and the enhanced text. A deaf person with non-standard speech can type what's in their mind. They don't have to write full sentences or worry about grammar, spelling, etc. Sunva will complete the partial sentences, correct spellings and grammar, and then speak it aloud for you. I welcome all of you to check the Sunva AI tool and interact with our work. Thank you. Sunva is an intelligent
sorry, I did something. Yeah, I'm back. So thank you. So as you can see, it's basically so in people per se we have something called a plus one philosophy. So it says that instead of reinventing the wheel, basically we take something that is abundant here and then add a plus one to it. So that we can, with the smallest effort or like with the small resources, we can make a huge impact. So in till 2 years before, this speech to text capabilities and real time processing and all, it was not that good. And every time a new application comes in, I install it and see, okay, will it help me attend an event or something? But then, most of the time it helped, but again, that cognitive fatigue and all was there. But again, thanks to the transformer architecture, the technology behind ChatGPT and all of these new audio applications, audio AI applications, now real-time processing of these transcriptions and in parallel using LLMs to simplify, concise, and all these things are possible now. So basically what we do there is, I will explain the architecture a bit. So the text-to-speech communication, previously we had to write the whole thing and then press a button to for the system to speak it aloud. Now we are trying to use LLMs so that person like Bharat or me can just type a few things. The LLM will fix the issues, expand it, and then ask it aloud. And I have seen some. So right now we are using some APIs and all, but I have seen better and better models are coming in. So now the text-to-speech models, it basically sound like a robot or something, but eventually it will get better and better, giving deaf people with the speech irregularities a very nice voice. And for the highlighting and concise part, what we do is instead of seeing the full transcription bombarded to you and taking you back from looking at the speaker or like looking at the presentation screen, we use LLMs to see, okay, this particular thing I have said can be concised or not. If it can be, we will concise it. If it cannot be concise, say, for example, somebody is talking about some big audio engineering pipeline and all. If I simplify it, I will lose the whole essence. So there, what we try to do is just highlight important terms. So I can still quickly glance and then come back to you. So this is the whole architecture. So the technology is used. So at People Plus AI, we are fully research based. So we wanted to quickly build a prototype and take it to the deaf volunteers and test, and then based on their feedback only we can iterate properly. So most of our efforts was with the APIs, available APIs. We used Grok. It's a fast inference API for speech, LLMs and all. We used that for automatic speech recognition in English. And there's we have partnered both the Navana API, so for in Kannada, Hindi, and other languages. And then we are trying Google ASR as well now. For the LLM layer, we are using OpenAI GPT-4 model, and then for English, and we tried Claude Sonnet and all for Hindi, but again, it's still not that working good. So text-to-speech layer, we used AI for Bharat in the TTS model. It's an open source fine-tuned variant of Coco TTS model. We use it for English, Hindi, Kannada, and Malayalam. So as you can see, Naima typed it in English, but again, you can use Manglish English or what do you call Tamil English? I don't know, but again, you can do that thing. But it will still do the TTS thing, thanks to the AI for Bharat models. We really need your help. So as you can see in the demo, the ASR have latency. Our real-time audio speech pipeline is still not that good because we still need to quickly get it to the deaf volunteers, take the perspectives, and then iterate. So right now we are doing the user search part. So in parallel, we would like to get help from open source volunteers with expertise in audio speech pipelines. We need your help in building a good real-time speech pipeline. And the English model works kind of good. We still need some fine tuning, but the real problem is with the Indic models because, as you can see, the summarization and all it will work, but highlighting important terms. But it's not just a summarizing, including key part and not missing the important part. That kind of things we still need to collect data set, fine tune LLMs and all for doing that thing. We need help. And then this is another big project we want to take after this thing. So still fun thing is like I still struggle with the Google consistency and all. Because I think most of you have understood what I said, but again, the computer systems are still struggling to understand my voice. And for people with a higher level of non-standard speech, it is very hard to use these technologies as well as communicating better. So we need to find and collect audio speech data of non-standard speech and fine-tuned model can be that can be used for speech to text transcriptions and all. So yeah, here we need help. So Sunva is a fully open source project and People Plus AI. You can find it here, People Plus AI slash Sunva. And we are looking for speech audio pipeline engineers, front-end engineers, back-end engineers for contributing to this effort. Yeah. Thank you so much, ADCx, and yeah, it's wonderful to be here. And I'm so glad that this kind of efforts are happening, because people like me, speech is something, I mean, listening and responding is a big challenge. And this kind of conferences, it will bring together people with like-minded thoughts and ideas, and then eventually we can build similar tools and all. Thank you so much.
Yeah, I think we can take some questions. So any questions? Okay, Arju.
Hi, thank you so much for the talk. So people who are interested in contributing to the project, how do you support the computation for the AI model training?
Who want to contribute to the project? How do you support the computational capacity?
We have some. So we have a machine, GPU machine in on premise in the office, but it's mostly for inference. But yeah, we have cloud credits and all for fine tuning and all. So based on the requirement, so this whole project is volunteer driven. Bharat and I are project anchors, and then we bring in open source volunteers and contributors to work with us. So based on the request, we can get credits. We have AWS as a GPU credit, so we use that for fine tuning and all.
Yeah.
Hi. Have you considered incorporating lip reading as well, or that's just a waste of compute? It's only audio or visual as well?
Yeah, so this is an interesting question. So this is just one dimension. The conversation. I mean, so basically, eventually, the goal is like, can we integrate multiple signals? So sign language is one option, replating is one option, but eventually, in general, how we deaf people communicate is based on multiple signals. So sometimes, we anchor into the lip reading, or sometimes your speech. Some people say, people have this weird idea that, okay, if I speak louder, the deaf person will understand. But the thing is not, I mean, it's a bit more complex. Like, say, for example, some people, even if they are loud, their tone and all, it still won't be able. So eventually the goal is, how can we integrate these kind of signals as well, like lip reading, and a combination of that thing will eventually help. We have seen some interesting project, like there's some project AI model that do not take any kind of sound. It will just take the lip reading and then generate captions. So that kind of models are coming in. So the future is exciting. So eventually we are trying to see if we can integrate these kind of signals as well to the project. Okay, got it. I think, yeah.
So since you are trying to make the process seamless of conversation, right? One question I have is, let's say the AI makes a mistake and something else is coming there. What's the correction mechanism? How's that being handled right now?
So, this is something. This is part of our user research as well. So so in US and all, we have a system called CART. So for education, so what they do is they keep a stenographer in the classroom, and while the lecturers speak, they type in very fast. Stenography, you can type very fast. That's how it used to be done before the pre-chat in the pre-chat GPT era. So we are trying to get inspired from that as well. Say, for example, can we add online or offline manual characters in a combination with AI? And maybe the AI can actually for every token output, we can get a threshold or accuracy or something. So based on that, maybe can we show, okay, something that could be wrong in red, so that this your other fellow here, or other student or your classmate can notice it, and then like a beehive mind. Say, for example, there are 2 deaf people in the classroom and there are 10 students, other students. So not everybody have to spend the time here, but again, people can randomly fix these issues. So these need to be researched. So we are taking this to user research and then try to see how these models are performing. And based on that, we need to build these pipelines. And some of these cannot be solved with the technology, but again, with a combination of manual plus AI thing. Yeah, it's a very interesting question because in a classroom or in a workplace, understanding things, misunderstanding thing or that kind things will mess up with the whole experience, right? So we are trying to figure out how we can do this thing. Yeah, thank you.
Yeah. Any other questions? I think I saw one more raised hand. Okay. Yeah, I think it's a really important topic to talk about. So thank you so much.
So thank you so much. Yeah.
Yeah, round of applause for Gopikrishnan and Bharat.